that? Welcome to the day 3 of whatever. Yeah. It started? All right. So, good morning and welcome to the third day of the Ethereum 1.x meeting. Um, I'm going to start with a quick presentation about what has been named the state of EWASM, but it's really the state of EWASM with respect to actually merging it into Geth in the foreseeable future. So the current, what we have with EWASM, we have a full-fledged implementation. It's available in several PRs. I should have changed slides. Why is that not happening? Okay, so we have the a PR called the EVMC. We have a reference implementation called HERA that uses Binarian as a backend engine, and there's a Go version of that implementation, the full-fledged implementation, and that's using Wagon. So Wagon is the least performant interpreter that we have so far, but it's also written in Go, so it's pretty practical for testing. And yeah, we have a test net running, so that's I encourage you to go and visit it because it doesn't receive a lot of visits. So if you want to learn about EWASM, if you want to play with it, you can. And if you have some feedback, we're really interested in that. When it comes to Ethereum 1.x, however, we're having a more as most of you know, we're having a more constrained version, which is to use the WASM engine as implementation for precompiles. And there's also a PR for that. And I'm in the process, so I started working on it like 2 weeks ago, 1 week ago. So it passed the unit test, and right now I'm using Rinkeby, like I'm syncing Rinkeby to test, to try to find out all the problems. So I managed to sync up to 25% of Rinkeby, and it's not because it's not syncing properly or there are errors. It's simply because I haven't been able to get a stable connections with all the ports available in the last few days, but it's working well. There's a bit of a problem on the SHA-256 precompiled, but apart from that, everything is fairly functional. It's just a matter of finding the errors. Yeah. Yeah.
Hello. Okay. So just to clarify, so what you're doing is that you're taking the precompiles that already existed, but you re-implemented them in EWASM and running them EWASM rather than running it natively. Is
exactly.
That
right? So there's a repository in the EWASM organization that's called EWASM precompiles, and they are a re-implementation. And some of them are fairly optimized. All of them are written in Rust, so it has some disadvantages because the binaries tend to be a bit big. But apart from that, they're pretty functional. And yes, we re-implemented everything, and we're just comparing. It's just about finding challenges and errors. Yes, sir.
It doesn't have to be in Rust, right?
It does not have to be in Rust. In fact, I think for something like precompiles, it would be much better to have something very lightweight like C or even direct assembly. But yeah, Rust has some nice features. Like it's really a development tool consideration. So I have a pre-benchmark that's going to get some people to cringe. As you can see, you can actually, or as you cannot see or barely see, you have the native implementation in yellow, and in purple you've got the Rust WASM equivalent. It's really taking much longer. By the way, I have 5 working contracts right now, and there's only 3 there. For 2 reasons. The 5th one, Xmod, is not used that much on Rinkeby, so I don't have enough data. And the other one, the EC Recover, the first one, is actually dwarfing the other precompiles, so I could not include it here, but it's basically the same phenomenon. It's much longer. So there are several reasons for that I will cover in the next slide. I just want to point out that even though it's not properly displayed, it's in microseconds. So it's not, even though it's way longer, it's still very fast for humans. And I think that was it. So yeah, you see that benchmark, but please don't panic. There are several considerations. The first one is that we're not going to. We had a conversation, like mentioned by Frederick yesterday or 2 days ago, about we're not going to replace like very critical path precompiles. We're just going to add the interpreter on the side to be able to add functionalities. But when it comes to something like EC recover that is used very often, I think it doesn't make sense to replace, especially with an interpreter-based precompile. So yeah, what's yes, sir?
Do you have any ideas where these 200 times come from?
Yes. So where do the 200 times speedup come from? There are. Once again, it's not optimized at all. So where does it come from? Well, first there's the actual execution. Instead of having an instruction, you go through the interpreter. So you have to do all the like for each operation, you do loops, you do memory accesses and things like that. What else? Yes, there's a lot of data copy because of the API we are using right now, which needs to be thought through in my opinion. Yeah, as far as I can tell, these are the two sources I want to look at. And once again, the interpreter is definitely not the most performant we have. So yeah. Okay. So precisely, the next step is to optimize. That's to get more data. Like the current step is about finding what the issues are going to be. So we're finding some issues. And then it's about trying to provide, to squeeze some performance out of this. So we want to try the GIT. We want to see if we can maybe use a different language, because Rust might not provide the fastest. That's what we were saying with the C. Might not be the fastest language for this case, for this use case. All right. And so the second part of this presentation is addressing Alexei's request to say, like, to see EWASM as a meta proposal and say what a proposal should have. So I'm reusing most of what has been said, but adding, throwing it a few things in. So the metering method that has been discussed, I'm not going to cover that. There will be a talk by Paul later, but that's definitely something that needs to be covered in a WASM proposal. There's the how do you link? Like so far, I was saying it's a bit slow because you have a lot of data copy. It's the way we pass. We're using the way we pass the data. We clearly need to investigate, or at least any proposal will have to suggest how the data gets passed from from the blockchain or the blockchain environment to the execution environment. What else? Yes, so very nice conversation with Brooke yesterday. Hi, about the migration path. This is something that I'm also part of the guest team, so it's about not just jumping the gun and pushing some interpreter and hoping, crossing your fingers to make sure everything, hoping everything is going to work. You have to be sure. So any proposal needs to cover that, and that definitely needs to be in the requirements. Right, so that's what I'm doing. If you have a proposal, you definitely need to be able to replay, or at least prove, based on historical data, that it would have performed or given the same results as what the EVM, or sorry, the native code, native code did. And yeah, so Robert here proposed 2 days ago to, for example, when you have a redundancy option, like space, like rockets or space rockets or planes do. So instead of running a single version of the interpreter at first, why not try to run several interpreters, several clients, and make sure that the result is completely consistent. And the last slide is about that a proposal should include is a list of precompiles. So I think the EWASM team wants to pretty much introduce what Blake 2. I'm trying to remember Blake 2, and is there another one? Some snark contracts, but that's still debated on our end. And yes, on a personal level, like I really find it really hard to work with. I mean, not really hard, but it's sometimes not very practical to work with the tools we currently have, and that's also the interest of switching to WASM. It's about grabbing like tools from a different community that tends to be, some of the WASM people come from the C++ world, so C++ has an excellent tradition of tooling. So getting that on board would be very nice, and I think a proposal should definitely list and explore that. And yeah, I think that was it. Yep. So if you have questions.
Hello. So in your slide about Hera EVMC,
Yep.
does that mean that EWASM is implemented in there as well? Or is it based on Hera? Or is it, I don't...
So there's an ERA-based version of EWASM, yes, and there's a Wagon-based version of EWASM.
Is the one which is based on Hera, is it written by your team, or is it like
Yes.
a third party? Is it written by your team?
Yeah, absolutely.
Okay.
Okay.
So people know Hera is the intermediate layer between the client and the WASM engine. The WASM engine is written by third parties. The intermediate layer glue code is written by us.
Right.
Anybody else? Questions? Okay.
Cool.
Well, thank you very much.
Yep, thanks.
I guess it can only go up from there, right? From those numbers, it can only go
It
better.
can only go down, absolutely.
Oh, sorry.
Yes.
It can only go down.
Yeah. And one thing that might not have been clear, yes, we expect it to shrink quite a lot. There's really no optimization there.
Okay, cool. Thank you.
Yeah.
Hey everyone, my name is Amir, and I'm with ZeroX, and I wanted to talk about a little bit about state rent from the perspective of a smart contract developer, with a specific focus on lockups and why I think the current proposal doesn't really work for most smart contracts. So, in an ideal scenario, every single time someone locked up Ether for a storage slot, that same address would be able to recover that Ether when that storage slot is released. Practically, this isn't very feasible because it would require an extra mapping of storage slot to user address, and this would end up doubling the storage size. The current proposal attempts to solve this by simplifying things a little bit and just maintaining a counter of lockups per contract. So just a quick recap of the current proposal. This might be slightly simplified. Every contract has a storage size and a lockup counter. Whenever someone modifies storage, if the current lockups are less than the storage size, then they will have to pay a lockup fee and increment that counter. Or whenever someone releases storage, if the lockups are less than the storage size, then they would release that lockup. And the lockup fee is always transferred to and from tx.origin. So this is meant to provide pretty much full backwards compatibility for older smart contracts. So we can imagine CryptoKitties, which currently is using a lot of storage size but has no lockups. So every single time someone transfers a kitty, they would have to pay a lockup and increment that counter until the lockups actually match the storage size. And this also means that any new contracts post-fork would always have a lockup equivalent to the storage size, and they would never have to actually pay rent on storage. Because the storage rent essentially you're only paying storage on storage slots that do not have a corresponding lockup. So before I explain why this breaks things, I want to talk about an extremely common smart contract pattern. This is the approve and call pattern. So any contract that interacts with tokens typically uses this. So a user will first approve the smart contract to transfer funds on their behalf. And then that smart contract will execute some logic and can transfer the user's tokens under whatever arbitrary conditions are defined in that smart contract. So what this means is that there is frequently a mismatch between the account that tokens are being transferred from and the actual caller or the tx.origin of the transaction. And what this pattern allows you to do is place intents to transfer your tokens at some later time, and that can later be executed by someone else by calling your smart contract. So quick example to explain what I mean. So let's look at a decentralized exchange. So we have Alice, who holds 0 DAI and 10 wrapped Ether. We just think of wrapped Ether as Ether, but it's like the ERC20 equivalent. And then we have Bob, who has a balance of both of these things. So when Alice purchases DAI, she will be paying a lockup fee because she now has a DAI balance, and that's using an extra storage slot that was not there before. Now let's say she wants to sell this DAI back. So she places an order to sell the DAI, and Bob comes in and fills that order. And now this will completely get rid of Alice's DAI balance and release a storage slot and release the lockup to Bob. So even though Alice originally placed the lockup, Bob is now receiving the release of that lockup. So this drastically changes the economics of the trades. Now there's a much larger incentive to only fill orders rather than placing orders. And it's also susceptible to front-running and race conditions. So let's say Bob attempts to fill Alice's order, and Alice decides to front-run that by transferring more DAI into her account and transferring all of the wrapped ether out of her account. Now Bob actually ends up paying a lockup fee rather than releasing the fee. So my proposal is to fix this. Rather than making lockups a mandatory part of every transaction that modifies storage, we should just create opcodes for locking up and releasing ether. And now smart contracts can determine their own rules around how fees are locked up and released. This is less backwards compatible because if we take the CryptoKitties example from before, now transferring a CryptoKitty would not actually change any lockups. You would have to write some sort of a wrapper smart contract that would do that for you. But it's much more flexible, and smart contract developers can actually change the economics of how things work to their favor. These opcodes are pretty simple. They would both just take a to address. The lockup opcode would always transfer ether from the caller of that opcode, and the release opcode would transfer ether from the caller as well. And now lockup fees would be included in the value of a transaction rather than, well, I guess it hasn't been fully defined in the current proposal where it's coming from exactly. Just some discussion points. Given that this proposal is less backwards compatible, and kind of thinking about Remco's presentation yesterday, I think we just have to basically define the types of things that we are willing to break and the types of things that we are not. By introducing these things as opcodes, we're breaking a lot of old contracts, essentially. The previous proposal provides a migration path for those contracts and is technically backwards compatible, but practically, I think the current proposal breaks those contracts anyways. They're not going to be economically feasible with their current structure anyways, and the contracts that are using a lot of storage are going to have to redeploy with new rules either way. Yeah, and in my opinion, breaking old contracts is much better than breaking an entire class of current smart contracts. And that's all I have. Apologize for the rough presentation just put together in the last 15 minutes. Any questions?
Can you go back one slide back? What did you mean with more flexible, the second point?
So contracts could, for example, decide not to use any lockups and just pay storage rent now. Or they could, choose to force people to deposit ether, which would later be used for storage slots that are relevant to that account, things like that. They could basically just define how lockups are actually included and released.
First of all, thank you very much for putting this together. Really good. So one thing I would note is that in the, I think it was the second slide or first slide where you were talking about release, I think there was a bit of a inaccuracy there. No, the before that. So yeah, so when you said the storage slot cleared, actually when according to the current proposal, if the lockup's less than storage size, then there's no release at all. So the release only happens when the contract is full, or when the
Right. Yeah.
So that means that for some time, if it's a pre-existing contract and it's really large, for some times there will be no releases at all. And my other comment is that, so if you probably know that the first ever proposal for the state rent was no lockups, right? And the main criticism there was that, well, what is going to happen to the existing contracts, because it's really hard for them to migrate. So the lockups essentially is the feature that wouldn't have been there if we were creating the state rent from the scratch, so without the legacy contracts. So it's simply there to provide the migration path. So yes, I agree that it's sort of a bit weird, and this is actually the Avihu first. We talked about it with Avihu here when I started to think about this idea, and I had exactly the same kind of criticism that you have to the lockups, where essentially it's tricky to figure out who is going to contribute the lockup and who is going to get it back, and things like this. And also, I thought, like, if you're about to withdraw tokens from the exchange, like the exchange now have to pay lockup for you because you didn't have any tokens, and then now you're going to be token address, and yeah, so maybe I thought, what the exchange is going to do, is it going to pay the lockups for everybody, or maybe it will start requiring people to have non-zero accounts before you can withdraw things. Yes, so there's a lot of these things, and thank you for start thinking about those. I just didn't really have time to list all these issues. Regarding, if you scroll back to your opcodes, I remember you asked me this question on the first day, yeah, about this. Yeah, I remember that. So these things are, so my question here to clarify, so the lockup opcode, when you say to address, is this address of the contract?
So this would mean that you could like arbitrarily deposit lockups into any contract.
So my question is that who has the authority to release that lockup to themselves? So when you do lockup, essentially, if you imagine what the effect is that in that to address a contract, there's another data that needs to remember who placed that lockup in there. So when you do release lockup, so you can't simply just sweep somebody else's lockups from there. So there's some to be permission mechanism there, right?
Yeah, so a smart contract would define how those, or who is allowed to call lockup and release, essentially.
And this is actually, to me, this is sort of almost equivalent to having the storage items remembering who locked them, who put the lockup in there.
Well, there's no requirement to do that. Like, you could have the lockups work in roughly the same way, right? A contract would just call this lockup function to itself every single time a storage slot is modified.
Yes. So what I mean is that it's previously you said that the reason why it's impractical to remember where the lockup came from, because it will inflate the storage, right? But what I'm saying is that it's also, the storage will also be increased, maybe not as much and only in adversarial settings with the lockup, because it does have to remember where the lockup came from. It's kind of the similar consideration.
I don't think it has to remember.
But what about if a lot of people place the lockup onto the contract, and now I go and do release lockup to that contract to sweep their lockups? How does that work? Or
well, you wouldn't lock up anything in a contract that didn't have a clear mechanism for you releasing that. Like, there are some potential attack vectors here, right? Like, you could just arbitrarily lock Ether up in a certain contract, and then that contract has a function where like the owner could just release all the lockups, and yeah, that's
so is the release lockup opcode really required? So is it because like does it actually affect the release or not, or does the store which clears the storage affect the lockup? Sorry, affects the release. So which action actually releases the ether? Is it the release lockup, or is it the store which cleared the storage?
It would probably be the release opcode rather than.
Okay, so in this case, I could sweep somebody else's lockups if there's no permissions in there.
Yes.
So if we want, obviously that is not okay.
Why?
Well, because everybody will be scared to put any lockups because somebody can just sweep them up, well, like miner or something.
Well, I mean, the contract would define its own permissions around it, right? Like.
But the contract, does the contract know basically, if you're thinking about the contract, in order for the contract to decide it, it needs the way to introspect the lockups. At the moment, there's no such thing. There's no ability for a contract itself to introspect the lockups. So it will not be able to decide because it doesn't have information. So the only thing that can decide it is a protocol. And in order to do that, the protocol will have to store the information who placed the lockup so that it won't allow anybody else to withdraw it.
You don't need to know who placed the lockup. You would just need a smart contract to be able to access the lockup counter, right? And it could call the release opcode as long as that lockup counter is greater than 0.
Yeah.
Yes.
The proposed opcode is that a contract can only release on its own balance. So you can't just call release as some third party. You can't call release on someone else's.
Yeah. So if there's like a to and from address, for this opcode, the from address is always just the contract's own address. So a contract can release its own lockups, and it can add to any other lockups from its own balance.
I guess I still don't understand it, so maybe somebody else can explain.
No, I just wanted to to see if I understood things right. So what you suggest is instead of, well, there is a problem. The naive solution to this problem is to store together with every storage cell who is the owner.
Mm-hmm.
And you suggest that instead of doing that, you can let the contracts choose which logic they want to go with. They could go with the logic of having this, like for every storage cell have the owner, which will cause them to double the storage, or they could go with different logic of how you release the lockup. So for example, you could choose that the contract owner would pay it, or any other logic that you want to build on top of that.
Yeah, and calling the lockup opcode would still increment the counter of the two addresses lockups. So that part doesn't change. If you wanted to add something where you actually were mapping storage slots to user address, you could also do that.
Maybe we could talk about it, but I still don't understand how the problem of permission is going to be solved. But we can talk about it after your presentation. So.
Sure.
So I think it probably needs a bit more specification, right? But let's talk about it.
I mean, like for example, if a contract didn't have any function that ever called the release opcode, then it would never be able to release lockups, right? They would just need to define some function with some permissions.
What in my mental model, I have in front of me two contracts. One of them, the one is the contract who actually executes the release code or lockup code, and then there's a second contract, which is the legacy one, right? Which we couldn't redeploy.
Yeah.
Is this your mental model too?
That is probably how the legacy contracts would work.
Yes.
You would just have a wrapper contract that deposits to. Yeah, I guess.
Because maybe we're thinking about two
hard.
different things. I'm thinking about legacy contracts. You're thinking about brand new contracts, which do the lockups for themselves.
Yeah, actually, I think you're right. It might be impossible for legacy contracts to actually release the lockup.
Yes, so that's the thing I want to bring up is that the only reason why the lockups have been put into proposal is to cater for legacy contracts, and I want to put it more in and to sort of give them a chance to migrate. And if we were to ignore that, we would simply go on with the first proposal, which is just a simple rent. And I agree with you that for the newly created contract is not ideal. The lockups are not ideal. So maybe I will go and think about it. Thank you for this proposal. I will go and think about it, whether it's possible to not have a lockups for new contracts. What implication does it have? And because as we are kind of realizing that the lockup and release opcodes probably not going to work for legacy contracts, so we are basically having now 3 different considerations: rent, lockups for legacy things, lockups for non-legacy things. So yeah, we kind of need to bring it together in a coherent place.
Yeah, I think that's a fair proposal as well. Only have the lockup scheme for older contracts, but I think if we were to move forward with the current proposal for future contracts, it would horribly break everything.
Okay. Anybody else wanted a question? Ask a question? No? Okay. Cheers.
Okay, cool. Hi. So, my name is Esteban. I'm a little bit of a foreigner to the all core devs meetups and everything, but a little bit background about me. I started working on Ethereum about 2 years ago. My project is called Decentraland. It's kind of like a game with virtual real estate. It's a small NFT in terms of contract size, but each NFT is pretty valuable. I run a bunch of nodes for a long. I have been doing that for a long time. I've got a little bit of a conservative background because I come from more of the Bitcoin side of stuff. So my main takeaway from this meeting is that I thought that there was a lot more consensus on keeping the 1x chain sustainable. I really like that hashtag sustainable. And I think that I'm going to try to push forward for more people to realize that this is a huge problem. Like in 2018, it's been a little bit of a pain to run a full node. And it seems to be becoming more of a pain every day. I just run faster machines with better hardware, but yeah, that's not sustainable. So I don't want to repeat everything, but these 4 numbers were something that was pretty interesting to have in mind for all of these conversations. Sorry. So first, the current stage size, 9 gigabytes. Running a full node that takes 140 gigabytes. I knew that already. There are about 50 million accounts out there, and we could consider about 30 million of those Dust accounts, and there are about 140 million storage items. So first, with regards to running accounts, I think that this is like the low-hanging fruit in terms of everything. We need some data to realize how much are we going to win from this. or if it's even worth to prune a lot of account data because of all the pains about resetting the nonce. But I think that it's worth it because we don't know how much or for how long will people continue to use this chain. And make it sustainable over time is a lot better than just saying there's going to be a cutoff, and after this moment there's not going to be like your account may live forever or wherever. So the account maintenance fee, I find that it may be like independent of the contract maintenance fees. I think that is pretty simple. I'm not going to explain it again because we already saw this about 3 times. I learned about the account eviction, how we should add these expires at TX field. It will be interesting to encode this into the nonce, but I think that may break some stuff. With regards to the contract storage maintenance, my slides have been just outdated by the conversation about 5 minutes ago, but I started to work towards the same, probably the first storage rent proposal, and I'm thinking that we shouldn't refund storage lockups. But I'm a little bit conservative, as I already said. A lot of the complications are coming from releasing the logs mostly, and I think that it may be okay if we just wait until people lose their contracts. This is what I think may become a tragedy of the commons for smart contract developers. If there's not enough incentive for people to release the storage, over time it's going to become too expensive to maintain that contract, and it may be so that the contract gets evicted. And I think it may be okay because it's a little bit of a separation of layers. I'm not sure about that. I also believe that charging tx.origin is a little bit of an anti-pattern, but we already discussed this. Regarding sync, I wasn't able to spend much time with the team, but it's clearly a priority for the team. It feels to me as an outsider that there needs a lot more coordination between the different client teams to work on a proposal to sync together. And then there are another thing that I learned was about increasing the gas limit, which I think it's a little bit reckless right now, adding more features, which will be cool, but I think that we need to fix the scalability first, and reducing the gas cost for cold data, which I also think it's kind of increasing the gas limit. So I think it would be a little bit complicated. So I don't know. I think that's kind of my takeaway from the whole thing. Thanks for inviting me, and it was a pleasure.
So with the TX, or you said that using TX origin for lookups is an anti-pattern. I did actually think, before I arrived at this, I settled with the TX origin, my first idea was to use the MSG sender for that purpose, but then for some reason I quickly realized this is going to be anti-pattern too. And then there was another idea to store where the lookup came from. So all of these things have problems, and I settled for the ones which I thought was the least of anti-pattern, which is the TX origin. So I don't know if anybody has an idea what it should be, or maybe saying that lookups don't work at all. So yeah, let me know.
I thought that there may be some solution where we could have a new call opcode that sets the lookups to be spendable. So the problem is legacy contracts, and legacy contracts usually use message.sender. So you cannot wrap that contract in a contract that before every store or whatever tries to do something else. But if we can find some kind of condition to wrap, to change the semantics of SSTOR if the wrapper contract calls in some other way, and maybe there's a solution regarding that.
Yeah. You don't need to propose the solution now, but I just encourage people to think about what are the other ways. So I just want to say I'm not completely set on this idea. It's just to me it was the lesser of many evils. Well, thank you very much. So I'm gonna go back to what we've discussed yesterday and show you what I've changed so far. So sorry, my name is Alexei. So I'm going to show you what I have changed in the couple of documents since yesterday after our discussions. Let me just open it. Okay. There's lots of things happened yesterday, but let me do this. And this again. Okay. And actually, okay, so first of all, I have renamed this document to. Oh no, actually, maybe I haven't renamed it. Anyway, so the page 4, 1, 2, 3, 4. So yeah, so something that I said on the first day, and then Robert has pointed out that I probably need to put it into presentation, is that in this framework for the state management, we are ignoring the cost of running the full node. So it's not addressed in this framework, and that's to make sure that we can kind of have some reasonable things that we can reason about, and we only concentrate on the performance from different dimensions. So page number 9. So page number 9. So here's the you might remember that might recall that I was also talking about caching. So for some of the performance degradations, like the reading the state from the transactions and writing the state from the writing the Oracle tree. Obviously, most clients use caching policies, and at the moment, probably the only one which is used is the LRU caching policy. And so my thesis was that if the caching policy is fixed and deterministic, then it could be DOS attacked. And at the moment, I don't think it's happening, but maybe it actually does. So all these things need to be analyzed if we want to make sure that it is actually happening. Because sometimes you have this really weird slowdowns of the Ethereum, like mind syncing. But if we started to analyze what was actually happening there, then we might see all sorts of things. We might have already done. There might have already been these DOS attacks, but we don't. They were just basically generally slow down the network. But I didn't see analysis on that. So for that reason, for the purpose of figuring out the the function of the performance degradation, we should not rely on the caching being able to kind of help a lot, and therefore we just assume that the cache is randomized. So page 12. Okay, so in page 12, I was listing the partial mitigations for the performance issues, and
just a quick question on the previous slide. Do you
Yeah.
mean cache hits, or the DOS is when you construct cache misses?
So with the DOS, what I mean by this DOS attack is that somebody, if the adversary knows the predominant caching policy, let's say ROU, the ROU basically has this hypothesis that if the item has been used now, it's very likely it's going to be used very soon, right? So if the adversary can basically make sure that this is not true, and essentially defeating the efficiency of this policy. So basically making sure that the transactions are happening, they're only using the items which haven't been accessed for a long time.
Okay. That's cache misses, right?
Yeah, to generate as many cache misses as possible. So so what I'm saying is that you cannot say that you have improved performance by simply putting the cache on the thing, because that cache could be attacked.
Question here as well regarding cache. Removing the LRU and replacing it with the randomized, if I understand correctly, that's the suggestion?
Well, practically you probably won't do it, but
right.
Theoretically this is the only cache which is not attackable by this.
Correct. Right.
Practically you're probably still going to run ROU for the case of simply processing the blocks, but as I discussed with some people in here, if you're actually syncing, then ROU is not an optimal policy. The optimal policy for syncing is that if you know in advance what you're going to be touching, you can basically have an absolutely optimal policy. But this is what I was planning to do in the TurboGet at some point when I have some time. So page 12. So basically here we were discussing the possible mitigations of our performance issues, and you might recall there was a mitigation to improve latency but not throughput. Then you can do advanced syncing. Actually, you can forget about this last modified block. We have the little breakout today about the sync protocols, and I'm hoping to put together some presentation maybe today in the afternoon to summarize what we've done. But I now want to add a third item here, one of the mitigations, that we can ask people to increase the pruning threshold. So essentially that's a saying that Ethereum node is not 140 gigabytes anymore, but it's 300 gigabytes officially. And that means that everybody should try to keep a bit of more history to allow the other peers to sync properly. I know this is just a temporary mitigation, but it could help. If we determine during our emulation that in 2 months' time it's going to be impossible to sync, this is the easiest mitigation. It's just to ask somebody who has to run the node to increase the pruning threshold. And here as well, yesterday I think Frederick mentioned to me, when we're talking about success rate of snapshot sync, I was previously thinking about only 3 variables that affect it, like 3 main variables, which is state size, bandwidth, and pruning threshold. But now he said to me that there's another possible causes that appears uptime. So I kind of assumed before that all the peers that they permanently online, but in reality they always drop in and out of the network. It's sort of it's very sort of ephemeral. So we also need to test for the peer uptime, like what happens when the peers like only temporarily in, and then there's, you cannot have basically persistent sync connection to the peer. You have to be able to find your, like, where did I stop? Like, how do I find to resume my sync or something like that? And this is this is all about this document. I'm going to show you the other document.
Okay, one point here.
Yeah.
Would something about like average number of peers you're connected to also be included in the function?
Oh yes, good point. Thank you. I'm just going to write it down.
When we test this.
Yeah, could you grab the microphone? Well, okay, so let me show you the other one. Okay, Esteban, have a question?
No, I've got a note there. I think that the sync should be a little bit more independent of who are you syncing from. Like, it should be better. Like, you talked yesterday about a chunked proposal for syncing, and I think that's going to be a lot better.
Yeah, so we are, just before we started the presentations, we had a little breakout session over there about syncing mechanisms, and I'm hoping to put together, I have some PDF about this already, but if I have time before the afternoon, I'm going to put something together and explain what we discussed. So first of all, this is the version 3 now, because there was previously was version 2, but version 3 is not published yet. So first of all, I renamed it from state rent to state management, and it's not just because we don't like the word, but it's because it actually overgrown the state rent now. It's not just about state rent; it's about lots of other things. And so let's see what we have here. So you might recall there was this diagram of the changes before. So here I started to make more clarifications. So I've realized that, for example, the replay protection EIP that Martin has written specifies that the first step, which is the optional replay protection, is a hard fork, but the second step is actually so-called soft fork. So this is the cloudy bit, like soft things. And I just explain you what is the difference. So the hard fork is essentially adding the new, so it's extending the protocol, meaning that certain things which were not valid before will become valid now. So that's the hard fork, extension of the protocol. And the soft fork is the restriction of the protocol. Certain things that were valid before are not valid anymore. So in the example of the replay protection, when we make the optional, we allow the optional field in the transaction, means that we still allow the old stuff, but we also extend it to the new. So we allow more transaction types to be valid, and then we restrict it. We remove the old way of doing things and only leave the new things. That's the soft fork. Another thing I added here is the S in the left bottom corner, which is the advanced sync protocol, and I introduced the non-fork changes here with the circle, with the oval, which basically don't require the protocol upgrade, but they're still quite important, and they should be on a roadmap. It's like a priority sort of number one. And then we discussed yesterday, and we kind of realized, I haven't formalized it yet, but I will do it, so that the accounting of the storage size potentially can happen with only one hard fork instead of two. And this is why I put it in an oval instead of the square. And let's see. So this is kind of a bit messy now, but I needed to lay out these things because they're not really nice circles anymore. But what you could see that the circles are now dropped out of the forks altogether because they're not forks. And another thing which we didn't realize, well, we didn't realize yesterday when we were talking about. So we were talking about what is the shortest path to, let's say, increasing the block gas limit. As the Esteban correctly mentioned, increasing the block gas limit right now is a bit reckless, because we will probably see the acceleration of the state size growth. But we still want to do that, and what are the minimal set of changes that allow us to do it without being reckless? And if we are looking at this particular proposal here, probably storage lockups will slow down the state expansion sufficiently so that it's not going to be, growing very fast. And yesterday we assumed that this could happen in a first hard fork, but now I'm thinking it's not. The reason for that is that the proposal I had yesterday, or before yesterday, there was this thing about lockup safety. So I'm just going to show you now. So it was a bit tucked into the last, yeah. So in this slide I talked about max lockups. So the problem is that because the lockups are not tied to the gas and they directly deducted from the TX origin or released to the TX origin, there is the only restrictions of how much ether could be deducted is essentially the gas cost of a store relative to the gas of the transaction and the balance. So it's conceivable that there could be some rogue contracts which have a goal of draining your account and putting it in lockups. So as a safety feature, in the same vein as we have a maximum gas limit on transaction, it would be prudent to introduce something like max lockups, which is like number of lockups that you allow this transaction to do on your behalf. Let's say if you put it as 5, then the moment it goes to the 6th lockup, the transaction reverts and no lockups are made. So you can basically limit how much ether your transaction can spend on lockups. If we agree, that it is important, then the situation changes that the storage lockups can only be introduced in a second fork, because before that we need to introduce the safety, the lockup safety. So I included the safety I combined it with the replay protection because these both changes modify transaction format. And it's probably easier to do them together so this is how it's going to look like. So change A, optional temporal protection and lockup safety. So now I have a little icon here to signify if it's a hard fork, but I haven't finished on the whole presentation. So the temporal protection we've seen before, but now this change looks like this. So I also take into consideration what Casey said about versioning. So let's say that we add 3 optional fields. They either all together there or none at all. Version valid until and max lockups. And then in the change B, together with the protection, we also make the mandatory version valid until and max lockups. And so this now becomes, because of the safety feature for lockups, we add it as a prerequisite for the lockups. Let's look again. You see that there's a little line between the B cloud into E. So that's the safety thing. And because the B cloud now can only happen after A, so the A will be in the first fork and B together with E is in the second fork. But then the second fork gives you both storage lockups and a dust account eviction, so it becomes sort of more impactful. So what other things I changed here? So yeah, so I haven't finished writing this yet, but I'm trying to write down what we thought about the gross contract size accounting. Instead of splitting into 2 forks, we're just doing it 1 fork, but now I turned it into the implementation guideline. So at a change C, this is up to the client implementation, but they start maintaining the signed integer count, and whenever they execute a store, they do these things to this counter, and then in a change D, this needs to be rewritten, by the way. So at change D, they inject the correct value into the state after the block D. So this is how you can achieve it in 1 hard fork. But actually, if you look at this, it probably, no, it still actually makes sense. Yeah, so this is what I've changed since yesterday, and don't think I've changed anything else. Yeah. Okay, so that's it for me for now. Any questions? Can you give a microphone?
Yeah, so the proposal is becoming quite complex. And
Well, it only looks complex because I didn't put them into nice layout.
Yeah, I think it's time to maybe start doing long form documentation of like the rationales for why some alternatives were being rejected. But off the top of your head, maybe, so I'm wondering, going back to like the the state rent proposal from Felix and
Yeah.
Martin Swendy.
They're still here. They're still inside this proposal. They are basically, apart from the fact that apart from the floating rent, everything is still inside here.
Okay, but their proposal, it applies on, it adds rent to existing contracts.
Correct.
Right? In this one, does rent happen on existing contracts or only the lockups?
So in this proposal, there's three types of rent. There's a rent on accounts, which applies to everything, to contracts, non-contracts. Then there's a second type of rent, which applies only to the code. The longer is your code, the more you pay. And the third type of rent is the storage rent, which only applies to the contracts which didn't lock enough Ether into them.
Okay, so it does apply on pre-existing contract.
Yeah, so the storage rent in this proposal mostly penalizes existing contracts, and it does not penalize the new contract. And this is the reason. Well, this is why it's basically meant as a garbage collection mechanism.
I'll announce the eviction of dust accounts as a separate proposal from the storage, because that makes this a lot simpler. Like, it's just adding an expiration date for all transactions and then evicting your account if it doesn't, if it didn't pay the rent.
Yeah, it's separated here, right? You see that?
Yeah, exactly. Yeah. But in general, when communicating it to other groups.
Yeah. So this separation, I only came to this idea on Monday, like last Monday. So it's a 1 week old idea. It didn't really have time to propagate yet.
Yeah. A, B, and G are. Like,
yeah, I will need to rejiggle this diagram because it's just organically grown into this thing. and of course we still want to hear the opinions and maybe modify this. So it's not like this is it. We keep changing it.
State management of the graph.
Yes. Any other questions? Go. Thank you very much. And anybody else want to make a presentation for now, or we doing a breakouts? Okay, I take it as no. Okay, we're doing the breakouts now, so the live stream will be suspended for a couple of hours, I guess. Thank you very much for listening.